Hello and welcome to the C++11 Beginner Tutorials by Gamer2Creator. I'm Chris. Recently we've talked about functions and function parameters. There's also something called a method. Now a method technically is a function, only it's object-oriented. Now what we're going to do to show you an example of this, we're going to click these little minimize buttons. They don't change your code at all, they just minimize it. As you can see, it's on line 51, our code ends at line 58, and it's still line 51 and 58. It's just an IDE feature. So we can hide some code that we're not looking at right now and save some space. Delete this new clear line. So now we can see almost our entire file at once. So we're going to make a method. Now remember, a method is basically a function, but it has a different name because it's an object-oriented function. An object does something by a method. So it's another name for a similar concept. Now here, we can actually put a function within our class, and that becomes a method. So, for an example, we're going to make this employee able to print itself to the console. Now that might sound familiar, because right here we have a function that prints an employee to a console, but it takes in an employee. And when we would call this, we would call it like employee imp equals get employee from console, and then print employee to console imp. So as you see, to get these functions to work, we have to pass around employees, copies of them in fact. So like when we get our employee from a console, it actually creates one in here and returns a copy of it down here, which we then have to assign to this one, which calls the assignment operator, and sets its values to equal the one that was returned. And then here we actually send in a copy of this one, which then prints out the values of the copy. So using object-oriented programming, we can clean this up significantly. So let's get started. But fundamentally, it's going to be doing the same thing, just in a more modern style of programming. And you'll see that it actually makes it easier to reason about this code. And I'll move this one above, just because it seems more fitting that way, but it doesn't matter. So we have a function to get an employee from a console and to print a console. As you can see, I didn't put the word employee in here, and you'll see why. You could, but it'll be redundant. So we're going to move this down. This is the old way of doing it, using just functions. We're going to do a new way. We're going to make our new employee, but we haven't actually put anything in here, so we need to fill in this space. So we need to give these methods, bodies. We're going to use count. Enter first name. then we end the line. We send m name first. And then we do send not ignore, which by the way is a method call. And now count enter last name. So as you can see, this looks a lot like a function. And we're just going through and getting from the console each one of our class variables, also known as fields. And there we go. Now, as you'll notice, this does not return anything. We could return something, but we don't have to. And we don't have a return statement. So how does this work? How do we get an employee from console? We'll fill this function out later. Well, we have our new employee here, and we want to fill it out from the console, but we're going to do this with a method. So you use the new employee, and then just like accessing one of the fields, you push dot. And then we could access one of the fields, but now we can also access these methods. These methods are part of the class. And we're going to use get from console. We put in our parentheses, and we're good to go. Now, it's important to see that the difference between this function call, or even this one, and this one, that we use the dot operator on our variable, and that says in relation to our new employee object, call its get from console method. So this is going to call this method, which is then going to come up here, start right here, and do this code. Now because this is part of the object, but not just the class, but an actual instance of it, this one. So it knows the instance, and it has access to the data that this instance has. And that's how we're able to use syn on it. How this works under the hood is that there's a pointer to it, and it's passed to the method, but it's a hidden pointer. You don't have to understand that just yet. But to access it, you use this. It's a keyword. And as you can see, if you use this arrow syntax, you have access to everything that is in this particular instance of the class. Again, that probably won't make any sense to you since we haven't gone over pointers. But we'll get there, I promise. But for now, all you need to know is that you can put functions within a class definition and they become methods. And this method carries with it, whenever you call it on an instance, it carries with it the instance. It knows about this particular new employee, and any changes we make to it within this method will exist down here because it's not copied. So this line and this line are pretty much equivalent in that they end up with a employee that has been filled out from console input. But this way is so much more pretty because you have your object that you're trying to get from console, and then you have your function that does that, and they're intertwined on this line. Now we're going to do the same thing and basically do what we did on this line. We're going to print it to the console. So we created our method up here, but we haven't put anything in it. So now we need to print this thing to the console. And we'll do this really easy. Count first name, first line, count. Now again, because this is a method, we have access to the variables of the instance we called it on. So let's call it new employee dot print to console. And as you can see, the object that you're working with becomes clear. It has its data, which is in our variable, and it has its methods that it does stuff with that data. And this is object-oriented programming. Now let's see this in work. We're going to comment this out. First, let's run it to make sure this works. First name, I'll do, I don't know, Chris Rock. I don't know how old he is. Let's just say 30. He makes like $1 million. I don't know. And then it prints it out, just like that. Just like we did before. Only now we're object-oriented programming. As you can see, we don't have to do all these copy operations. We don't have to copy here. We don't have to create a new employee in here and then copy it out and then assign it to this one and then copy and all that other stuff. Instead, we create one. It has its own data. Just like here, we can still access this data or whatever. But we can also access its methods. And then we can tell this object to do stuff with its data. So we're going to simplify this, and we're going to make a player class. I keep going back to that because it's a really great example. That happens a lot in games, and it's kind of a real-world example that you can start linking the idea of objects in code with objects in the real world, and even just objects that are kind of logical, that don't exist in the real world but are a logical object. And we'll get into that later. So we're going to delete this. We're not going to work with employee anymore. We don't need these anymore. In fact, I'm just going to delete. That can stay. So we're going to keep our employee and our get in from console. We're going to make another class. It's going to be player. And make it public. We're going to have a float x float y. And then we're going to have a, doesn't return anything, but it move x. And let's call this move x. This is the variable. This is the name of the method. They're similar, but they're not the same because this doesn't have a capital. This would be a little weird. I don't think this would even compile. Let's see if it does. Wow, it does. Okay. Anyway, let's just make this 2x's. It's just a name. It doesn't mean anything yet. And I'll get into why we can't just name this x right now in just a couple of minutes. First, we're going to define these. So this method, the idea behind this is to move the x coordinate by the x parameter that we passed in. This parameter, xx. So we do x plus equals xx. Y plus equals yy. Again, yy is just the name. It could be d, as long as we use it properly both times. But why we can't call it y. Wow. If this parameter was the same name as the field, we would have a conflict. Now it thinks that this x is the parameter. As you can see, it turned gray because I have the syntax highlighting set to making parameter names gray. And so this is not going to do what we want. We have an ambiguity here because this one is named exactly the same thing as this one. So that's why I put XX. So now they have different names and everything works. So we have our player class and he has a position of X and Y. Now we can use methods to modify his data. We'll make a player. We'll call it the user. Now user dot x equals 100. User dot y equals. We'll do 100 again. Now in your program you will often want to move your player around on X and Y. And now we can say user dot move X and call that field, or excuse me, method, and send it how many we want to move it by. Let's say 50.f. So after this method call has been executed, down here user's X position should be 150. We can print that out. Now let's try it. And as you can see, it works. We've created our player, we've assigned X and Y to 100, and then we used a method to modify that X and send it in the parameter of 50. Oh, sorry about that. So as you can see here, we've moved the user, his X float, that data, by 50, and we've used a method to do it. Now, because these are public X and Y, the alternative is to do .x plus equals 50.f. But doesn't this give you more information? It becomes closer to the English language. The user, move him on the x coordinate by 50. It gives you more information. What are we doing? What is x? And why are we adding 50 to it? Well, we're moving him on the x coordinate. So this is much more pretty and easily readable. And if you're trying to read someone else's code and you're like, why are we adding 50 to x? Why are we doing this to the user that's a player? This tells you we're moving it. So I hope you can see the benefits of doing it like this. Now we're going to do the same for y. We'll do minus 50. Because we're adding a negative number, then it's like we're subtracting 50. Or just adding a negative 50, which are equivalent. And we already wrote that method. That's good. Let me move this down. And here we'll print out count music dot y and line. And to prove this works, we have 100 plus 50, which is 150, and 100 plus a negative 50, which is 50. Now that we have methods, we're going to introduce in the upcoming videos a couple of things that's really going to make this object-oriented programming come together so that we don't do code like this anymore and move more into doing code like this. More on that in the next videos.